Hello and welcome to our LoadSlammer video for passive kits versus our FFED Xilinx kits. Shown on the screen right now is an example of one of our passive kits. All the way to the left, you can see our remote sense cables. Next to that is a LSP Pro 1000 RS for testing currents up to 500 amps. Below that is the stabilizer to help support the device. To the right of that, we can see our FSVA3824 for testing the VU19P platform. To the right of that, we can see our protector mini. Above that is a PTO, which is power takeoff. And above that is the LSP Pro Mini 200 for testing currents up to 100 amps. To the right of that, we can see an example of DC power cables for doing power takeoff. Here, we can see a VU19P FSVA3824 passive adapter. This would allow us to be able to test the 5 rails that are on here, as well as monitor some of the other smaller rails using an SMP Mini. At the top of the adapter, we have a large connector for testing VCC in. To the right of the board, we have a smaller connector to be able to test the VCC aux. On the bottom of the adapter, we have a connector to be able to test VCC and I/O. On the bottom left, we have another connector to be able to test MGTY, AVTT, and above that, we have a final connector for MGTY, AVCC. The small connectors in the middle of the board are SMP Minis to be able to test smaller things or monitor for things such as VCC, ADC, and VBAT. You would be able to connect a SMP Mini to a scope to be able to monitor these rails. Here we can see the bottom of the VU19P FSVA3824 package. This matches the XY package dimensions of the VU19P designed by Xilinx. Let's connect some of these devices together to show how it works. If you're going to be using less than 100 amps, then you may be using the LSP Pro Mini 200. If you're using higher than 100 amps, then you'd be using the LSP Pro 1000 RS. The connector below allows it to support the weight of the LSP Pro 1000 RS. By sliding it over the connector, we can apply support and then place our LSP 1000 RS within the connector. Now we connect our remote sense cables to be able to monitor the voltage of the rail we're slamming. If we'd like to do some thermal testing on the board to do continuous testing, we would use the PTO device. We connect our PTO into the Samtec connector. We then grab our power takeoff cables. By applying some pressure to the top of the cube, we can squeeze down and insert the cable. You would then do that for the negative side as well. Once you've connected your power takeoff device, you would then connect the slammer on top of it. If you'd like to do some slamming on one of the smaller rails, you would use a small protector, making sure we align it in the right orientation with the negative and positive voltage. We want to make sure it's oriented properly with the voltage sense pin on the 200. Now we're ready to start slamming on one of the smaller rails. Now looking at a much more advanced kit, our FFED kit, we can look at the VSVD1760 package. We can see at the top we have a ORAC ADJ, which is the brain or controller of this kit. And below that to the right, we have the FFED, which stands for Form Factor Equivalent Device. Connected to that is a ribbon cable, which goes to what we call the pod for switching the rails to be able to control what we'd like. Now we'll take a look at how to connect these devices. We would simply have our device reflown onto the board we'd like to test, and then we'd plug our ADJ into the pod. This is all that needs to be done to set up our FFED kit. We would then connect the USB connection and the power to the top of the ADJ, which would then allow us to control the FFED connected at the end.